Let's look at the derivative of sine x. These are some key notes we'll be using. So to begin with, we'll label our function f of x as sine x, and the method we'll be using to work out the derivative is differentiation from first principles. So the formula says f dash of x, which is the derivative, equals to the limit as h tends to 0 of f of x plus h minus f of x all over h. So using this formula, we now have f dash of x, which equals to the limit as h tends to 0 of f of x plus h. So that would be sine of x plus h. So we can write that in brackets, minus f of x, which in this case is sine x, all over h. Now, since we have sine of x plus h, we can now use the addition formula to simplify this. So we now end up with f dash of x, which equals to the limit as h tends to 0 of, so in this case, x is equal to a and h is equal to b. So substituting into the formula, we end up with sine x times cos h plus sine h times cos x, and then we have minus sine x, and all of this is all over h. We can now rewrite this as f dash of x equals to the limit as h tends to 0, and now we'll write sine x cos h minus sine x all over h, and then plus sine h cos x all over h. And so what we've done here is we've split the fraction into two as well as rearranged the terms. Now we can write f dash of x equals to the limit as h tends to 0, and now in the first term here we can factorize sine x out, so that gives us sine x multiplied by cos h minus 1 all over h, and then we have plus, and so writing the cos x in front, we then have in brackets sine h all over h. We can now use the small angle approximations for when h is in radians. So we have that sine h approximates to h and cos h approximates to 1 minus h squared over 2. And so we get f dash of x, which equals to the limit as h tends to 0 of sine x. And now in brackets, instead of writing cos h, we'll use the approximation, which is 1 minus h squared all over 2, and then minus 1 all over h. And then we have plus cos x. We'll use the small angle approximation of sine h, which is h. And so we get h over h. If we now simplify this, we get f dash of x, which equals to the limit as h tends to 0. And now inside the brackets, we can cancel out the 1's, and so we then have minus h squared over 2 divided by h, which then gives us minus h over 2, and then we have plus cos x, and now h divided by h simplifies to 1. If we now apply our limit in the next step, we get f dash of x, which equals to, so instead of writing the limit notation, we'll now use this limit within this function. So we get sine x, and now wherever we have a h, we'll replace that with 0. So this then becomes minus 0 over 2, and then we have plus cos x times 1, which is just cos x. And so this then becomes f dash of x, which equals to, so minus 0 divided by 2 is 0, and then 0 times sine x is 0, and then we have plus cos x on the end. And so we can write in cos x. And so therefore the derivative of sine x is equal to cos x, using differentiation from first principles to show this.